Thank you so much for joining us as we go through vocal biomarkers of neuropsych disorders. So I am, by profession, a statistician. So as a statistician, I'm always interested in looking for patterns, numbers, identifying different attributes which might help us to better understand health conditions. So today we are going to be learning about how problems with our voice might also signal problems with our health. So I do intend this to be a about 10-minute talk with 5-minute questions after. So please, I would love all of your questions in the comment windows that we can go through them and identify together what the best way is to identify how changes in our voice make changes in our health. So this is my little guy. He's my 4th baby, and he was participating in his first research study at UCLA when he was 6 weeks old. And we have very complicated brain imaging techniques now to identify what happens when a baby is born differently, wired differently, and the same with adults. What do brain patterns look like when someone has a diagnosis like schizophrenia, for example? Because these techniques are newer, back in the good old days, they had to rely on more primitive things. And one of these more primitive biomarkers that people were interested in analyzing was voice. So this is a paper from 1962 that is looking at differences in cries of babies with and without brain damage. Now, this is significant because this is something that is experiencing a renaissance now, but this field isn't new at all. We've realized for about 60 years that babies who have medical problems cry differently. So, for example, you see differences in babies' cries not just with brain damage, but you also see it with Down syndrome, Cri-du-Chat, perinatal complications. Basically, it means that your voice is a window into your health. Cri-du-Chat is probably the most famous of these disorders, even though it's extremely rare. So Cri-du-Chat is a disorder where you are missing part of your 5th chromosome. So it's 5p minus syndrome. And it produces very characteristic changes with the baby's face. They also have low birth weight, weak muscle tone, and they have a very characteristic cry, which we are going to listen to. This cry is still considered diagnostic, even though we have genetic testing to identify whether or not a child actually has Cri-du-Chat. So that squeaking is a baby crying who has Cri-du-Chat. Now, if we wanted to get more into pathophysiology of how our voice is generated, there are 3 different systems working together, but a lot of the pieces of the nervous system rely on the cranial nerves, which are located at the base of the brain. Now, we have 12 cranial nerves, but 7 of these are associated in some way, shape, or form with speech. And disorders in these can, for example, affect not just our voice, but also our face. So when people have a stroke, you might see half of their face drooping. They might have weakness in their arm, and they have what's called dysarthria or slurred speech. So what does it sound like when somebody has dysarthria? So we're going to watch a real patient who's had a severe stroke, and you can listen and try to identify the vocal changes that have occurred in him due to the stroke.
Excellent. Okay. Now what I'd like you to do, I have another picture, and I'd like you to take a look at this and tell me what that object is right there. What is that right there? Can you tell me the name of that object?
Globe.
Excellent.
Key. Chair. Cut.
Mm-hmm.
I cannot pronounce it.
Mm-hmm. Okay.
Cat. Cuts.
Good.
So when this gentleman had the stroke, it led to weakness in him not being able to pronounce the words. Now, one thing you might have also noticed that the pitch of his voice was very low. So I cannot pronounce the words. It was almost like he had been to the dentist, but the pitch was also lowered. Now, this is important because we're going to go back to it in just a second for baby cries. But before that, we're going to look at a few other disorders that happen in adults. So do we see differences in other disorders, such as, for example, schizophrenia? Well, the answer to that is yes. So this is a brief recording of a patient who has schizophrenia. This was also taken in 1961. This was a real patient from UCLA. So we're going to listen to his voice and try to identify changes that we see in him and how he speaks.
How are you feeling? Well. How long have you been here?
About 3 months, May 17th.
And what brought you here?
That's difficult to answer.
Could you give me some idea?
Well,
Whose idea was it that you come here?
a psychiatrist.
And what happened that ended up with your being here in the hospital?
The psychiatrist decided that this was the situation for me.
All right, so we do see with this man with schizophrenia that he has characteristic changes that really have him possess a very monotonous voice. So he sounds somewhat robotic. I don't know why I was here. Now, these changes aren't unique to schizophrenia. We see them also in other disorders. So every single psych disorder has a commonality of symptoms with other disorders. So for example, schizophrenia is also tied with schizoaffective and bipolar disorder. And if you have one set of symptoms, you often have another. So for example, in schizophrenia, motor retardation is tied with blunted affect, which means the person is not animated. They're very lifeless. You can see it in their mannerisms. They're not going to move much. You see it with their voice. These symptoms are also tied to depression, another disorder in which vocal changes have been observed. Now, for our third adult disorder we're going to look at very quickly is Parkinson's. So we're going to look at probably one of the most famous patients with Parkinson's, Michael J. Fox, and listen to his voice before and after his diagnosis and listen for changes that might have occurred. Now, one thing that we should note with Parkinson's is that the symptoms you do observe are highly dependent upon whether you are on or off medication. And if I had to guess, in this case, the patient is probably on medication because you'll notice some very jerky movements that he's making that are caused not by the disease, but the medications. However, even with these excessive movements, you can also note some differences in his voice before and after his diagnosis. So we're just going to listen to them right now and try to observe with our own ears some changes that might be associated with the disease.
Well, the thing about it is that, for me, this movie was a reaction to, I find that there are so many people that take what I do far more seriously than I do, or I am able to. In other words, the people who analyze films and actors and stuff, and they would ask me questions about why would you do a serious film? All
right, so that is him before the disease. So let's try to hear him after his diagnosis. Now, one word with Parkinson's is that often it's not diagnosed until you have about 90% of the changes in the brain already accomplished. So he was likely already having some symptoms before, but we just weren't as observant of them yet.
I like that you call, I like that you call the book Always Looking Up and why you did that, because
It's a bit of a short joke.
it's a short joke. Yeah.
I don't know if you can say this, but my world growing up was mostly asses and elbows. and in the same way, too, the second part, the Adventures of an Incurable Optimist, is also
Yes.
a pun on being incurable.
Incurable.
Okay, so we can notice before and after his diagnosis, there's definitely a change. His projection is a little bit more strained. He's really trying harder to get his voice out. This is tied not just to changes inside his larynx, but really his entire body is going to be changing. For example, it's going to cause rigidity in muscles, difficulty in projecting, and these are going to lead to vocal changes that we see associated with the disease. The most common vocal features we see associated with Parkinson's, however, is a very soft voice. So when people have Parkinson's disease, and you might notice it, when they typically have a very soft voice, which is very hard to hear. So the volume is low and it's just very soft because of these changes that make it harder for them to project. Now, we did very quickly stroke in adults, so let's try to hear a stroke in babies. Do babies have strokes? Yes, it's very common to have a stroke either when you're old or very young, but not really in between. And this is because when babies are getting prepared to be born, they do have an excess of red blood cells, which leads to greater likelihood of clotting. Now, this is something that Mother Nature gave us so that when a baby goes through the birth canal and there's an artery connecting them to their mother, they should be clotting more quickly and have more oxygen in case there's any sort of delay in them being able to breathe independently. So first, we're going to listen to a cry of a baby who's a control, and then a baby who's had a stroke. And this is the baby. I'm sorry, this is the stroke baby right here. Now, these cries are part of a large database of cries we collected at UCLA through something known as the ChatterBaby study. Now, in the ChatterBaby study, we launched a free app to collect cries from babies all over the world, and we built AI algorithms to predict why a baby's crying. The motivation behind this in our lab at UCLA is to identify whether or not vocal changes may precede an autism diagnosis or another neurodevelopmental disorder. So the ChatterBaby free app, we listen to the baby's cry, it goes to our server, we run algorithms to predict why the baby's crying, and in this case, we're able to identify that the baby needs a bottle. Now, we use this by looking at different signatures of the cry by creating spectrograms from it, and our most recent paper, which is published in Nature Pediatric Research, identified that colic was painful. Now, our algorithm is meant to go into other devices as well. So since we've launched it, we've been trying to get this into other devices. And one thing we're always interested in is looking at potential collaborators. And for that, then, I guess our asks for this are for collaborations. Anyone have ideas of research projects, collaborators? I would definitely love to get in touch with everyone about this. All right, I think we are now ready for questions. So please shoot them my way. Thank you. It's a pleasure to hear from you or to be part of your audience. I'm going to type my email address again in the comments. Oh, do you study focus excessively on babies, or do I do adults with other baby diseases as well? Absolutely other diseases. We are planning on collecting data from adults who are engaged in mindfulness practices. Basically, any study where we're able to get vocal features, we do want to study. And that is because the techniques used to analyze baby cries, the algorithms don't identify or don't know whether or not it's a baby or an adult, and they are really able to work on different populations. Okay, cleft palate. So cleft palate is comorbid with other disorders as well, as you might know. So your jaw structure changes sound. Do you know of any neurological disorders related to speech? I'm not sure if this question is asking about changes associated with a cleft palate, but I will tell you in general, there are several mechanisms that are associated with differences in speech. And one of them is changes in muscle tone. And basically with most CNS disorders, you do see changes in muscle tone. That's common across Down syndrome or babies who had stroke or epilepsy. In fact, our lab just did a study recently where we were identifying whether or not babies with brain injuries, so that includes stroke, epilepsy, brain tumor, do they cry differently than babies who don't? And we have found yes. Interested in correlating to emotions? Absolutely. As I showed in the schizophrenia video, there are ways to identify characteristic changes, and people are already doing this right now with depression. It is likely that we're not going to narrow it down too much as to what the issue is with someone. So for example, if I gave you a voice of someone who was severely depressed and someone who had catatonic schizophrenia like the man we saw, it might not be possible to tell the difference between the two. So you're able to identify something's wrong. You can identify in which direction it goes, but it's going to be difficult to parse it any finer than that. Is it known which disorders have a leading signature in the voice? Yes. So there have been research studies which have shown that babies with autism cry differently as old as 2 months of age. Now, the average autism diagnosis doesn't go until 3 or 4 years of age. So that is one. My guess is there are many others, but yes, there are ways to identify changes in your voice that precede the other changes. Language independent. Yes, they are language independent. Now, the reason for that is that when we, for example, are in pain, we see our face get grimace. We have red face. We have increased respiration. There's many things that change our muscle tension, which also changes the way our voice projects. Now, the grimace, the pain face, isn't something that's distinct to just people living in California. It's a worldwide expression. So if I showed you someone from places throughout the world, you would be able to look at them and identify whether or not they're in pain. Yes, please follow up about partnership. We're very, very interested in making collaborations. This is a research project, but we definitely want to be able to make our research commercially available to people who are building devices. Thank you. Any other questions or ones that I've missed? I think that might be all. All right. Thank you, guys. Have a great day. And please reach out to me if you have any questions. I'd love to hear from you and chat with you more about this.